and good evening, everyone. Welcome to this new episode of the series of talks that Astronomisk Ungdom is organizing with Stockholm University. Please keep your microphone muted unless you have something very important to say, and write in the chat any question you come up with during the talk. So first things first, let me introduce myself. My name is Mattia, and I'm a PhD student at Stockholm University in the Department of Astronomy. I come from Italy, and there I went to high school in a small town near Milano. It was a high school class focused on physics and mathematics. And during those years, I realized how much I like to solve problems, especially in the subject of physics. So it was a natural choice later to do a bachelor in physics at the University of Milano. But I discovered my passion for astrophysics only the last year of the bachelor. During this year, I was doing my bachelor thesis, and the subject was black holes. The attraction of black holes was simply too strong, and I went for a master in astrophysics in the same university. But the first year of my master, I was in Erasmus at Uppsala University, and this was my first time in Sweden. Then I went back to Italy the second year to do a master project at the Observatory of Milano. And here I had the opportunity to do research with really top astronomers. And I decided that I wanted to do a PhD in astronomy. So I applied to many universities across Europe. And one day I received an email from a professor at Stockholm University offering me a position as a PhD student. So here I am in Stockholm now. But the topic of today is Hubble Space Telescope. The title of this talk is Happy Birthday Hubble, because this telescope was launched into orbit around Earth in the 1990s, so 30 years ago. It has been looking at the universe, taking beautiful images for 30 years. And we'll see together now some of the most beautiful discoveries. First of all, what's special about Hubble? Hubble is not just a normal telescope, but is a space telescope. So it's looking at the sky from the space. It was launched in the 1990s, as I said, but the idea of a space telescope was conceived much earlier, in the 1940s, by an astrophysicist at Yale University. And this was a really revolutionary idea, because at that time, no satellite was ever launched into space. So not only a brilliant scientific project, but also a very challenging technological project. In the 1957, the first satellite was launched by the Soviets, and this determined the start of the space race between Soviet Union and the United States. The US government put a lot of money into space-related technology and science. And in those years, NASA was created, the National Aeronautics and Space Administration. A few years after, in the 1970s, engineers and scientists meet for the first time to discuss how to design and build Hubble Space Telescope. Hubble is named after a very famous astronomer, Edwin Hubble, who discovered the expansion of the universe. He was looking at galaxies outside of the Milky Way, which is our own galaxy, and he realized that every galaxy is moving far away from us, and is the farther away the galaxy, the faster it moves. So basically, he discovered that the universe is expanding, and is this guy here smoking the pipe. And finally, in the 1990s, Hubble was launched on board of a shuttle together with 5 astronauts. Astronauts were trained to perform operations on board of Hubble and perform spacewalks on top of the telescope. And this was really important because they soon had some issues. So if you look at this image on top of a galaxy, is a bit blurry, and all the first images of Hubble were like that, with a fuzzy halo of light. So this was a well-known problem in optics called spherical aberration, and basically it happens when the mirror of the telescope deviates from the perfect shape. Many components of Hubble were replaceable, but unfortunately, the mirror was not one of them. So they had to come up with some other solution. And what they did is to install an instrument that corrected for the flaw in the same way as a pair of glasses corrects for the vision of a poor-sighted person. So you can say that Hubble wears glasses. But a question you might be asking is, why observing space from space? Why making life so much hard? Well, you have 2 very good reasons to observe the universe from space. The first one is that Hubble can see in the ultraviolet light, also called UV light. Our eyes cannot see it because they're simply not sensitive to UV light. And as you might know, the atmosphere absorbs most of the UV light. So if you want to see objects emitting UV light that are in the universe, you need to go outside of the atmosphere. The second reason is also related to the atmosphere, and basically the air in the atmosphere is turbulent. So when you observe with telescopes from the ground of the Earth, the images are a bit blurry. Whereas if you observe space from space, there is no atmosphere on the way, and the images are way more sharp. But what's the difference between UV light and visible light, which is the normal light? To answer this question, let's go back to beautiful Italy. So in my home country, basically everyone in summer go on holiday on the seaside, on the beach. And it's very important to not forget sunglasses and sunscreen to protect the eyes and the skin from the UV light, because it's true that the atmosphere absorbs most of it, but still a fraction penetrates and can be dangerous for our eyes or skin. But to really understand what is the difference between this UV light and normal light, visible light, we should understand what is light. Newton was one of the first scientists that proposed a theory to explain light, and he believed that light is made of particles that travel on straight lines, and therefore they can cast shadows, as you can see on this image on the left. Many scientists after Newton, they found out that light is also made of electromagnetic waves that can separate according to their color or their frequency when they cross a prism, like in the cover album of the Pink Floyd. Electromagnetic waves are in a way similar to any other waves, for example, sound waves or the waves of the ocean. And the most important property of a wave is the wavelength, which is the distance between two bumps of the wave. So when you look at the electromagnetic spectrum, you realize that visible light and UV light are only a small part of a much wider spectrum of light. And all these kind of light, or you can also call radiation, have different wavelengths. So let's go through them, starting from the left. You have here radio waves that have wavelengths of the size of hundreds of meters, so like soccer fields. Then you have microwaves that you use to heat up your lunch, and they have wavelengths of the size of centimeters, like a baseball. Then you have infrared light with wavelengths of the size of a cell, visible light with wavelengths of the size of bacteria. UV light, interestingly, have wavelengths of the size of virus, like the famous coronavirus today. And X-rays, going to shorter wavelengths, have the same size of water molecules. And gamma rays, finally, with wavelengths of the size of atoms or even smaller. One thing you might realize is that these types of radiation on the right, UV light, X-rays, gamma rays, are well known to be dangerous or potentially dangerous. And this is because the shorter the wavelength of an electromagnetic wave, the more energy the wave can carry. And that's why they can be more dangerous. So, long story short, the difference between visible light and UV light is the wavelength. And Hubble is able not only to see visible light, but also UV light and actually infrared light as well. Another question you might be wondering is, who can use the Hubble Space Telescope? Every astronomer from every country and from every university can use Hubble Space Telescope. Or at least it can ask request some observing time. So every year, the Hubble team releases a call for proposals, and astronomers are invited to write a proposal where they request observation time to observe their favorite galaxy, for example, and do their research. But as you might imagine, Hubble, since Hubble is such an amazing telescope and many people want to use it, it's really competitive. So you really need to write a strong proposal and convince the panel that your research is simply the best. So you need to have a clear scientific question you want to answer. You need to explain why you need to observe this galaxy, for example, this year, and why you want to use Hubble, because it's not the only telescope. And so together with your team of collaborators, you need to really convince the panel with all this information. And after all proposals have been sent, the panel decides which are the best, the most cool projects, and they assign telescope time, and they will observe the objects that astronomers have requested. All right, we've come now to the second part of this talk. And in this second part, I will show you 4 of the best images that Hubble took during these 30 years of space exploration. Probably you will see more in the next talk by my colleague Timmy. But let's start with this one. This is a spiral galaxy that is called Vera Rubin. named after a female astronomer in the US who was studying the rotation curve of this galaxy. This is a spiral galaxy, and like all other spiral galaxies, they basically are flat disks. It's very similar to the Milky Way, for example. It's also a flat disk, and these flat disks are rotating. So they are disks made of billions of stars, and each star is moving into space and circulating around the center of the galaxy. And this is exactly what Vera Rubin was studying, the rotation of this galaxy. He measured the velocity of the rotation, and he also calculated the velocity using the gravitational force. However, he found something really puzzling. The value of the velocity that he measured was larger than the value calculated with the gravitational force. And the only way to explain this was to assume the existence of some material at the center of the galaxy that had a very large mass, but that is invisible. And this has been called dark matter. Many other experiments after this confirmed the existence of dark matter, but we still don't know what it's made of and why we cannot see it. So it's still a very open field and question in science, in astrophysics, but more broadly in science. This is a photo of Vera Rubin, and she was a really great astronomer, and you must think that it was not easy to be a female astronomer at her times. In the 1950s, she applied for a PhD at Princeton University, but she was rejected. And Princeton would reject female graduate students for 27 more years. Then she applied, she started a PhD in another university in US, and at the same time she was pregnant. And during her career, she did really important discoveries in astrophysics, and at the same time she had the resources and energy to raise a family. So it's really a guiding light for for women nowadays that wants to have a career in science, at the same time have the resources and energy to raise a family. This is the second image I want to show you. And it's a really cool one. It has been released this year for the 30 years anniversary of Hubble. And what's the major difference between this and the first image, the spiral galaxy? Well, it's the size. The size of the object we are looking here, it's much smaller. It's 1,000 of times smaller than a whole galaxy, because this is a star-forming region. So it's not much larger than the size of a star. And how it is possible to see with so much detail a star-forming region? Well, it's possible because this object is very close to us. It is inside the Large Magellanic Cloud, which is one of the two Magellanic Clouds, and they are the closest galaxies to us. They are two small satellite galaxies. They are called satellite galaxies because they orbit around the Milky Way. And if you go to the south hemisphere, you might be lucky if the sky is quite dark, because they are actually visible with the naked eye. And I was lucky actually last year to see them with my naked eyes when I was in Chile, in the desert of Atacama, during a summer school of astronomy. But going back to this star forming region, what are we looking at exactly? So you see this large red cloud is a cloud of gas, and inside it, many young stars are being formed. But how do you form a star? So to form a star, well, you need this kind of cloud of dense gas, and because of high density, the cloud collapses in several points. And when you reach a high temperature, the nuclear reactions are ignited, and each of these high density points they start to shine, and a star basically is born. So there are many different types of stars, and what you see here on the lower left corner, you see a blue star that is one of the most powerful stars. It's called Wolf-Rayet star, and it releases very strong radiation and very strong winds. So that's why you see this bubble of gas that is blowing away. This is the third image I want to show you. And this is another spiral galaxy. What you see here in blue, it's the stars of a spiral disk, but it looks different from the spiral galaxy we saw before. And it's not because it is really different, it just looks different because we're looking at it under a different angle. So remember that spiral galaxies are flat disks. Here we're looking at the edge of the disk, not on the face with the spirals, but on the edge. That's why it appears different. And in red, you see instead filaments of gas that is being pushed away out of the galaxy because there is a very strong galactic wind. This kind of phenomenon is also called gas outflow. Yes, you understood correctly. It's basically a space fart. And these kind of phenomena are really important for the evolution of the galaxy because the life of a galaxy consists of transforming gas into stars. And when you blow away the gas, you simply run out of gas inside the galaxy, and you cannot form stars anymore. So when a galaxy stops forming stars, it dies and becomes passive. Another object that is very important for the evolution of the galaxy is the black hole. Here in the image on the top, you see the representation of a black hole as in the movie Interstellar that you might have watched. But on the bottom, you actually see the first image ever obtained of a black hole. It was taken now almost 2 years ago by a network of radio telescopes across the globe. And it was a really extraordinary image. So it's quite impressive that black holes can have an impact, an influence on an entire galaxy, because the size of a black hole is much smaller. Nevertheless, if you see on the right, you see the galaxy. That this bright spot here is the galaxy that hosts at its center this supermassive black hole, and this jet, which is a jet of material moving very fast, almost with the same speed of light. And this jet can reach very, very long distances and even go outside of the galaxy. So this is really impressive. Finally, we have come to the last image I want to show you, and this is perhaps the most beautiful and inspiring. It's the Hubble Ultradeep field, and what we're looking is the deepest zoom into the faraway universe that we have ever made. So the size of the sky we're looking at is the same as we would see by looking through a 8-foot straw, and each bright spot in this image is a galaxy that is very far away into space. And what's fascinating is that when you look far away into space, you also look back into time. And this is because light takes time to travel. It is true that light is the fastest thing in the universe, but its speed is finite. So to travel intergalactic distances, you can take billions of years. And in fact, these galaxies emitted the light that we observe today 13 billion years ago. So we're looking at some objects that lived 13 billion years ago, and the age of the universe is only 14 billion years ago. So the galaxies that we see here, they are the first galaxies that ever formed in our universe. All right. Hubble has been taking beautiful images and given us, allowed scientists to make really important discoveries. But it will be in orbit and operate for a few more years. And then something else, something even perhaps more extraordinary is coming. And it's the James Webb Space Telescope. I have a video here to show, but actually I don't know if it's gonna work out with the audio. We can try. I think I should yeah, I can try to turn this on. But maybe we want to switch off this instead.
Yeah, sure.
Okay. Let's see if it works.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest primary mirror ever to be flown in space at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown, a 5-layer, tennis court-sized sun shield that blocks heat from the sun, Earth, and Moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique? Launching such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket fairing. Engineers designed it to be folded, like origami, to squeeze inside the European Space Agency's 5-meter diameter Ariane 5 rocket fairing. After launch, controllers on the ground deployed Webb remotely. Deployment is an intricate ballet. For nearly 3 weeks, controllers carefully unfold Webb. After this delicate dance, Webb's golden mirrors are precisely aligned using motors behind each hexagonal mirror segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Webb is a technological challenge like no other, born of the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe, and our place in it.
I guess you can mute me again. All right. All right. Last thing I want to mention is the exhibition at Fotografiska about the 30 years anniversary of Hubble. I really recommend it, and you have the opportunity to see some of the large prints of some of the images that I showed you during my talk. Thanks for listening, and if you have any question, don't hesitate to ask. You want to come closer?
Can join. I can join. I was wondering about the James Webb Space Telescope. And I was wondering what you were interested to see coming from it. Is there anything in particular you're interested in?
Myself?
Yes.
Okay. Actually, my supervisor, PhD supervisor at Stockholm University, is she's a professor in astronomy, and she's writing a proposal to observe, to use James Webb Space Telescope, this telescope that is going to be launched very soon, hopefully next year, into space. And she wants to observe a few galaxies, and in particular, she has been involved. She has involved a lot of collaborators from universities in US, and I'm also part of the team, even though I can do a very small part. But I'm very excited to be part of it. And the goal of this scientific project is to look in the infrared and see the the formation of stars in clusters at a very early stage of formation. So when the clusters, the stars are very young. Yeah.
Well, thank you, Mattia.